A big thank you and welcome to all of you who have subscribed to your channel. I greatly appreciate this. We have been growing so much in the past few weeks. If you haven't subscribed yet, please consider doing so and help us reach that next milestone for 100,000 subscribers. This is the most number of displays I ever have on set. What you're looking at right now are 6 total displays that are turned on. And third time's a charm, right? This is the third time filming this whole thing because I want to present the information in the most clearest and concise way possible. We're going to talk about the M1 Pro and M1 Max when linked up to an external display, the different connection type, calibrations if there's any issues, and also I've run numerous tests with multiple different programs to see where and when the slowdown is starting to happen when we start to scale up the displays and as we start to link up more displays into the system. So let's find out together. This is Artist Right. Before we start, subscribe if you're new and hit on the bell icon so you'll be notified every time I upload cool new videos like this. You may notice the set looks slightly different. Well, this is future art. After filming and editing, I realized the video is going to be rather long, so I have decided to break this down into 3 separate parts. Part 1, which is what we're watching now, will cover the introduction, we'll talk about cable connection, we'll establish the baseline for the test that I am going to do, and I will also show you the result from Final Cut Pro. In part 2, and the following videos, which will be released in the following consecutive orders in the following days after this video release, will be on Capture One, and I will show you multiple display connection scenarios and when Capture One slow down. And part 3 will be on Lightroom Classic. And that will be the conclusion for these multiple display tests. For now, let's jump into part 1, talking about external displays on M1 Pro and M1 Max with an introduction by Past Art, and he will also show you the result from Final Cut Pro. And if you stay until the end, there is a bonus feature where I will show you the 2019 16-inch MacBook Pro with the top Intel Core i9 processor, 32 gigabytes of memory on board, and also the Radeon Pro 5500M with 8 gigabytes of memory, and see how that performs when we're just really linking up to 2 displays. So stay tuned for that. As usual, this will be information rich. I'll leave timestamp to the various section in the description below. Let's have a look at the test reference system I have. There are 3 of them. One of them is the 14-inch MacBook Pro, base M1 Pro processor, 8 CPU, 14 GPU, 32 gigabytes of memory. The next one is a 16-inch MacBook Pro M1 Max, 10 CPU, 32 GPU, 32 gigabytes of memory. And the last system is a fully upgraded one, 64 gigabytes of memory on the system with the same top M1 Max processor. And as much as I call all of these processors, they are technically a SoC system on a chip, so I will use those terms interchangeably. But one thing that I want to point out about these M1 Pro and M1 Max is that there are a display engine on these chips, and you can kind of see the mark for the display engine and how many displays that it would support. What I really like to know is, are these display engine really doing any job to help facilitate any of the heavy lifting from the GPU, or are they just really there to facilitate display connection? And we're going to find out as we go through these tests. I want to quickly talk about external display in a little bit more detail. So on the M1 Pro, you can only link up 2 external displays, and both of those can be up to 6K resolution. Where on the M1 Max, you can do 4 display total. 3 of them can be up to 6K, and the last one will be a 4K resolution. But in the setup that I have here, I'm linking this to 4 4K displays. This is not going to be a problem whatsoever. Another thing I want to mention about the M1 Pro is that if you already have 2 external displays linked up to the system, and let's say you close the lid down, run it in clamshell mode, and you link up another external display, it won't send any signal to that display whatsoever. So that means that the system can only handle 2 external displays total. And if you open your lid up and use the internal display, then you have 3 display total, 1 internal, 2 externals. One thing that we have to remember about these SoC is that they use a unified memory. This is another reason why I'm advocating that Pro should get 32 gigabytes of memory, just so that if you ever need those, you have them and you can grow with the system a little bit more. And the memory that are being used here is not just being used by the CPU as it is in the past, whereas there is a dedicated memory for the CPU, another dedicated one for the GPU. Right now, it is all shared, and we have to consider that too. So if you're using an application that are GPU intensive, that are memory intensive for the GPU, you may want to consider adding more memory to the system. Another thing I want to touch on is fan noise before we get started and show you any result whatsoever. In my testing, there are no fan noise whatsoever between the 14 and the two 16-inch model that I've run a test, even when I link this up to multiple different displays. So one of the other few things I want to touch on as well is the display connection and the type to the display. For instance, this is BenQ PD3220U and it has a Thunderbolt type connection and it supports display daisy chaining. That display right now, SW271C, is linked up to this display via Thunderbolt daisy chaining and it works just fine without any issues whatsoever. This display up front here, the SW271, is linked up using a HDMI cable, and BenQ SL 55-inch display back there is linked up using a DisplayPort to USB Type-C connection. So you can see they are all running at 4K and I can scale the resolution differently, and they're all running at 60 Hz. So no issues connecting external displays, and also I've run calibration on external displays, both software and hardware calibrated displays, and there are no issues whatsoever. One thing that I want to talk about before we get deeper into the test is the way how macOS scale. You're going to find something interesting that when we look into system information, for example, on both the Intel one and also the M1 Pro and M1 Max, for example, I have BenQ SW271C linked up to the system and I'm running this as scale resolution. It has the actual resolution and it has a UI lookalike. So if you translate this into the display system preferences, you're going to see similar to what you see on the screen right now. And you can go in and choose a different text size. For instance, you want to see less text but larger, or more text and it becomes smaller. And you will see that there is an equivalent resolution, what you're going to see on your display that shows up. And right below that, it tells you that it may affect the performance. And I'm going to go into a little bit more depth and explain to you why that is the case. So let's have a look at this for just a second here. Right now, I'm having this chart to show you a comparison between a 2K and a 4K native resolution, which you can see in those two columns there. And all of these are the scaled resolution you can see in all these four columns, and they correspond to these four selections that you have. So on a 4K display, if you start to scale all these things up, we're going to talk about the number of megapixels total that your GPU or the system GPU has to push out 60 times per second, because all these external displays that I have right now for Pro Workflow refresh at 60 Hz. That means the computer needs to redraw the graphics 60 times per second, and on all these external displays, there is no variable refresh rate such as the one inside the MacBook Pro. So this is something that we have to consider. So looking at the scaled resolution right now, for instance, if I'm using the smallest scale right here, you can see that I am pushing an equivalent to a 4K native resolution out. 8.3 megapixels 60 times per second all the time. If I start to scale this up, for instance, to a 2K equivalent, which is this column right here, I am pushing about 14 or close to 15 megapixels 60 times per second. That is a lot of data that the GPU has to render at any given time. So one thing that I want to point out is that this resolution right here is equivalent to a 5K display resolution. So what macOS does is that it renders more pixels in general and then it squeezes it down in order for it to fit your display. And that's how it does all the pixel binning on the system. If we take a look at the next column over, this is the equivalent to Apple 6K displays, and we're pushing around 20 megapixels out 60 times per second. And lastly, the most interesting one is this 3360, which I will be doing a test on because this is a crazy, insane amount of megapixel, 25.4 megapixel, 60 times per second that the system needs to push out. This is, like I said, a crazy amount of megapixels your computer has to push out. All right, so the two tests I'll be running is a 4K native, as I'm showing right now, and I will also push the system to the brink using the 3360 by 1890 and see if there's any slowdown that we can observe in various programs. As I already mentioned, the different displays that I'm using on set, behind me, this big one is the SL55 from BenQ. This is a digital signage display. It is the world first Pantone validated display. I have BenQ PD3220U, SW271C, and in the front is the SW271. All of these are 4K displays. and 2 of them are hardware calibration capable, software calibration, and software calibration, which is the one behind me. And now let's have a look at the test method. So this is not designed to simulate a real-world experience 100% of the time, but what it's designed to do is really stress the system out and see at what point are we going to start to experience a slowdown in the system. This is way more than anyone would use in the real-world scenario. So what I have is both Chrome and Safari running in the background, and all of these browsers for Chrome and for Safari, each of these browsers will have 2 windows open. On each of these windows, there'll be 1 active YouTube video playing and 3 website tab open in the background. That could be Engadget, The Verge, Apple.com, whatever that may be. So each of the windows will have 3 inactive tabs in the background, taking up memory as well. So for each of the browsers, we're looking at 8 tabs total. And when we combine these 2 browsers, we're looking at 16 tabs on the system. So this will also act not only just as an external display test, but also a multitasking test on the system to see when do we start to see a slowdown? When does the system really lock up or lag, and how capable these systems are? I will be doing the editing in Lightroom using just the regular sliders in the develop module, and also doing localized adjustments on 2 files. One is a 192 megapixel panorama and also a 36 megapixel Nikon D810 file to see if there's any lag when we do localized adjustment in brush as we start to scale up the number of displays. For Capture One, again, edit localized adjustment on 136 megapixel Nikon D810 and also 120 megapixel panorama just to see the performance and how fast it can render, because Capture One, unlike Lightroom, uses more of the GPU for rendering rather than Lightroom, which uses more of the CPU power to just create the render in general, and also utilizes the GPU at the very same time, but not so much as the CPU itself. And lastly, we are going to use Final Cut Pro to do a playback at 2 times speed on better quality, a 5.9K footage 10-bit 420 that comes from a Panasonic S1 shot with an anamorphic lens with de-squeeze going on and some color grading. So this will be very interesting to see. For the test template here, these are all the test template that I have. So we are going to start with the number of displays and scale this up. So you can see I'm starting with 2, 3, and then 4 displays. And for each of these, I'm testing this at 4K and also at scale. And you're going to see right in this line, 1 screen edit and dual screen edit. What this really means is that I'll have videos playing on other displays, but I'll be doing the editing on just primarily the internal laptop displays. Or if I'm doing the dual screen edit like this one right here, what I'm going to do is edit on the laptop screen and also have it mirror onto an external display on one of them to see how the performance is, and if we notice any slowdown, how capable these computers are, especially when we're pushing it this far. You will see that there are black cells, for example, there, and there, just because obviously the M1 Pro can't really test 3 or 4 displays, so that's not going to happen. As far as the M1 Max go between these 2 machines, because the base M1 Pro can perform fairly well in these tasks already, so I'm not really doing a testing on them. I'm doing this specific test though, however, because there is a slight performance in some of the programs, so that would be very interesting to see. And I literally just test this top machine on the very last category, because for all these things that I'm doing, I mean, let me just give you a quick spoiler right now. The M1 Max can handle it pretty much just fine. There may be some lagging here and there, and we're going to find that out really soon. All right, so for the test template, the first thing I'm going to do is show you and run you through a whole test that I have done for all these 3 programs. And what I'm going to do is use the M1 Pro 14-inch 1-screen edit running at 4K native just to give you an idea what kind of tests I'm running. I'm not going to show you every single one of these tests because this video will probably end up becoming like a 2-hour long video. But what I'm going to do is pick a selection for each one of the programs and then show you what happens. So let's jump into the first test and see what the method is and how the computer performs. To establish a baseline for our comparison, I'm going to start with the 14-inch MacBook Pro. This is the one with the base M1 Pro processor and upgraded 32 gigabytes of memory. I already have Chrome and Safari loaded on the external displays, and I already have Lightroom Classic, Capture One, and Final Cut Pro launched and running in the background. So far, we can see that the system has already gone in and start to do the swap on the memory. And we're going to see if I jump into Lightroom and start working on a panorama image with the 192 megapixel file, is this going to show us any slowdown at all? So let's jump in. So far as I'm dialing these sliders up and down, you can see that the program is being extremely responsive. Everything is showing me the preview right away in the develop module. And like I said, this is 192 megapixel panorama, so it is quite large. Let's do a sky selection, which it does take a moment to do because we have a lot of tasks running in the background. We'll click on subtract and we'll use the brush with auto mask. I'll zoom in and see if we notice any slowdown or if the system is having a hard time catching up running with 4K native. You can see right now that the screen, or the brush rather, is catching up with me just fine as I'm dragging across here. It is identifying the areas. There may be just some slight slowdown here and there, but it's extremely slight that you won't really notice it. And if you really go slow over these areas, for instance, the brush is able to handle this and catch up with what you're doing just fine, as you're seeing right now. All right, so now let's have a look at an image of the Aurora Borealis. So we have gone from a very large file. Let's go to a smaller file, 36 megapixel from a Nikon D810, and let's see how this is responding to the adjustments. So again, we can see as I'm adjusting this in and out, the program is really doing just fine. It's catching up. There's no lag, there's no delay, there's no spinning beach ball, which is a good thing. And let's do another select sky. Let's go in with the brush to subtract. We'll leave auto mask on, and let's see if I hover over these Aurora Borealis area, how does that look? So far, the program is responding splendidly well. There's no slowdown whatsoever. So we can see that even just the base 14-inch MacBook Pro with Lightroom Classic, it is an extremely capable machine. Let's now jump into Capture One. So in Capture One, I'm going to use a similar image, but this one I'm going to start out with the 36 megapixel Nikon D810 file, and let's go in to do some adjustments. So as you can see on this file, Capture One is able to handle this just fine, is following through on it, is rendering the preview extremely quickly. There are no slowdowns whatsoever. This is what I really expect to see, and even when we load the GPU right now, the system is doing really great. Let's go in and add a gradient in the sky, and let's see if there are any slowdowns whatsoever with this. So we'll darken the sky, increase the contrast, and maybe bump up the brightness. You can see that there are no slowdowns, and Capture One is able to handle this perfectly fine. Let's now look at another panorama. This is around 120 megapixel, and see how Capture One is handling this large file. So we'll go in to make the adjustments. So far you can see that the preview is handling really quickly, is working just fine. There's not a lot of problems there, which is a good thing that we want to see. Let's also throw in a gradient on the sky. And let's go in to make some adjustments. And as we can see, Capture One is able to handle this flawlessly using the GPU for rendering and performance. If we go up to the memory usage right now, we can see that we are increasing the swap, and that's a lot of it has to do with Lightroom because it is holding around 24 gigabytes of memory. But if you're not multitasking between all these programs at the same time, you should be okay. Let's jump into our last program. This is Final Cut Pro, and what I am doing right now is this is a clip that is filmed at 5.9K using the Sirui anamorphic lens, a full frame one. And because this is filmed at a pretty high resolution, 5.9K, 10-bit 420, I want to see how the playback is at double speed, because I know that on my Mac Pro, it is struggling, even just playing back on one screen. So we shall see if this is going to happen that way or not. And I can speed this up all the way. You can see that there are no frame rate dropping or any slowdown whatsoever. So obviously this can do just fine. So now that you have seen the test method that I used for each of the program and the performance of the base 14-inch M1 Pro processor with an upgraded 32 gigabytes of memory, as I said in many of my other videos already, that is the machine that surprised and wowed me the most from this generation computer. The M1 Max, we kind of have that expectation, but just having the base processor in general and how much money you're saving, I mean, that is a really strong contender. All right. Let's jump into Final Cut Pro, and with all these tests, I have annotated the way how they feel, the way how the program responds to the testing that I've done. In Final Cut Pro, I mean, this is a program optimized by Apple, and because it has an encoder decoder engine built into the SoC, where the M1 Pro has one of each, the M1 Max have double of each, I mean, the performance is pretty much good throughout, and there are no slowdown whatsoever when I'm playing back this footage. Just for reference, I will tell you right now that when I'm trying to play this footage back on performance or better performance on my 2019 Mac Pro with the Radeon Pro Vega 2 video card, 32 gigabytes of high bandwidth memory, it stutters and it does lag. And there are some drop frames where on these machines, even with loaded external displays, there's no drop frame whatsoever. So what I'm going to do here is show you a sample playing back in dual screen at scale resolution here on 4 external displays or with 4 external display link up to the system. And you can see that everything is extremely smooth when you're playing Final Cut Pro footage back. 2x speed, better quality playback. So far so good. There is no performance degradation or anything, no drop frames or stuttering that I can see, which is a great thing. All right, wasn't that impressive? I mean, considering that it's not just only playing that 5.9K footage on the external display, it's also playing on the internal display on the laptop, and it has other YouTube video playing, and all the while, none of the videos are skipping, there's no drop frame. I mean, that's just absolutely fantastic. Feature art again to wrap up part 1 and to show you what I'll be demonstrating with Capture One. So the one in red are what I'm going to be highlighting in that video when it is released, and also for Lightroom Classic. For now, make sure you subscribe and hit on the notification bell so you'll be notified when those videos are released. If you have any questions or comments, leave them below, give this a like, and remember, in art we trust. And here's the bonus footage with the 2019 16-inch MacBook Pro. The test is done in the exact same way as the M1 Pro, M1 Max. This is the top machine, which is 2.8 gigahertz, 8-core i9 processor, 32 gigabytes of memory just dedicated to the CPU alone. It has an integrated graphic, but right now, because we're pushing this so hard, it is using the Radeon Pro 5500M with 8 gigabytes of memory just dedicated to the GPU. I have Lightroom Classic, Capture One, Final Cut Pro running along with 2 browsers as we have done in all the other tests. So Chrome and Safari actively playing videos, and it also has tabs in the background. In addition, both of these displays are 4K, but they're running at scale resolution at 3360 by 1890, so they are pushing around 25.4 megapixels, 60 times per second to each of these displays. Now let's have a look at Final Cut Pro and see how this computer plays back a 5.9K footage with de-squeezing, color filter going on, and this is set to better quality. So I'll play it back at double speed. We start to see a stuttering already happening, although it did pick up a little bit. Not quite as smooth as the M1 Pro and M1 Max processor. Although it does pick up a little bit, there are some slight stutter here and there. And as I mentioned, this is set to better quality. If we go with better performance, let's see how this does. It is definitely much smoother, but we do see the pixelation on the display because it is pretty much scaling everything down. The great thing about the M1 Pro and M1 Max is that you can play this high quality footage back using the better quality setting, which is quite fantastic. And the fan is running like crazy on the system right now, compared to the other ones that are super silent.